So, good morning. I'm Carmen Novo, the Vice Rector for Internationalization, the University of La Rioja, and I want to introduce you to this event as we have today and tomorrow in our institution. On behalf of the President of the University of La Rioja, I would like to welcome to Atlas 2025. It is both an honor and a privilege to welcome you all to this inaugural session of the Atlas Network. Today marks the beginning of what I am confident will be an impactful and transformative journey for all of us, scholars, educators, and professionals dedicated to advancing the frontiers of language technology, artificial intelligence, and human-machine communication. Atlas, as many of you know, of course, was born out of a shared vision to create a global consortium that fosters collaboration, bridges geographic and linguistic divides, and pushes the boundaries of what is possible in language technology. This vision has brought us here today, united by our commitment to interdisciplinarity, innovation, and inclusivity. At its core, Atlas is more than just a network. It's a community where computational linguists, AI researchers, engineers, and linguists come together to solve some of the most pressing challenges of our time. From improving natural language understanding to ensuring ethical and efficient AI systems, the work we undertake here has the potential to shape the future of human-machine interaction, and by extension, the way we communicate, learn, and collaborate as a global society. Our efforts are rooted in two founding principles. The first is interdisciplinarity, because we firmly believe that the complexities of human language and its interaction with artificial intelligence cannot be fully understood or addressed in silos. By bringing together experts from different fields, we can unlock new insights that transcend traditional boundaries. The second principle is the commitment to efficient and accessible AI. We aspire to build systems that are not only powerful but also sustainable, capable of serving both highly resourced languages and those with limited datasets, thus ensuring that no linguistic community is left behind. Today's program is witness to this vision. Over the next 2 days, we will hear from leading voices in our field, tackling diverse topics such as adversarial challenges in large language models, ethical design strategies for AI, and the intersection of AI with humanities. We will also explore groundbreaking projects like the Robotic initiative and delve into the fascinating realm of computational paleography. These discussions will not only broaden our understanding, but also inspire us to think critically about the ethical and societal implications of our work. To those of you who are students or early career researchers, let me say this: your presence here is vital. You are the future of this field, and Atlas is committed to providing you with the resources, mentorship, and opportunities you need to thrive. To our seasoned professionals, your expertise and leadership will pave the way from innovative solutions and lasting impact. As we embark on this journey together, I encourage you to engage fully, ask questions, share your insights, and build connections. Let's use this platform to ignite new collaborations and foster a spirit of mutual learning. In closing, let us remember the immense potential of what we are building here. Atlas is not just about advancing technology. It is about creating a world where language and AI bring us closer together, where barriers are broken down, and where every voice is heard. Together, we can achieve this vision. Thank you for being part of this exciting initiative. I wish you all a productive, inspiring, and collaborative meeting, and let us begin this journey with enthusiasm and purpose. Thank you very much.
Well, good morning. Thank you, Vice President, dear Carmen. And I would like to welcome all the colleagues and friends who are going to meet us in the second meeting of the Atlas Network. I would also like to welcome the participants who are following the event through the streaming session. And I'll go straight to introducing the first speaker we have today. Actually, it's our plenary speaker. It's my pleasure to introduce Dr. Oluwaseun Seun Ajao. Seun Ajao earned a PhD in computer science from Sheffield Hallam University with a thesis on content-aware allocation, inference, and misinformation in online social networks. His work has been recognized with multiple grants, including funding from the Alan Turing Institute and Research England. Dr. Ajao is currently a senior lecturer in data science and artificial intelligence at Manchester Metropolitan University, with a remarkable background involving artificial intelligence, data science, and social media analytics. His research interest in NLP includes the study of adversarial attacks on large language models and the safeguarding of language models. His research has made significant contributions to detecting misinformation online and understanding content dynamics in social networks. Sean is principal investigator of the Social Media Dermatological Intervention Study in collaboration with the Northern Care Alliance at the University of Manchester, NHS, and is part of other AA LLM funded projects, including the UK's National Institute for Data Science and the the Alan Turing Institute based in London, and the Northwest Cybercom in Manchester. Dr. Ajao is co-chair of the LLM Journal Club, which focuses on advancing knowledge in large language models and generative AI. He's also committed to inclusivity in academia, coordinating the SPIRE program to widen postgraduate research participation among Black and Black heritage students. So please join me in welcoming Dr. Seun Ajao today.
Thank you very much. I mean, that was an excellent introduction. I couldn't have said it better. So it's great to be back. Thank you for having me, Javier, Hannah, and Madam Vice President. Nice to meet you. And colleagues, wonderful colleagues, from around the world that are back. Thank you for joining today. So today my talk will aim to look at an issue that we believe is a problem as well, because we all know AI is making the headlines, basically. And the contest for having the dominance of the space is becoming a challenge, both politically and even technology-wise. And we've had news also as well about graduate-level positions disappearing by being replaced with artificial intelligence and the rise of vibe coding. And you see things, the competition like this between Meta and OpenAI, being driven largely by the impact these models are making in the world that we are currently living, positively and unfortunately also negatively as well. So my talk today does not have all the answers, and I'll just share the little bit of the work that we are also doing at MMU with a few other colleagues as well. And I know, speaking with a few other colleagues yesterday when we caught up earlier, I think one of the things where we are seeing the transition from artificial intelligence, we started from machine learning, where we're just talking about narrow intelligence, and then we've now moved on to machine intelligence, where we currently are talking about deep learning models. We're able to overcome the exploding gradient problem and all that. That has led right to transformer models. And so that has brought up what we refer to as the AGI. And now we're moving on to the artificial superintelligence, where we have companies like Meta setting up the Meta superintelligence, establishments, and other ones like Safe superintelligence, with the hope to counter the existing ones. So And this is taking us to a place where people are beginning to think, or there's a school of thought, that machines themselves can become conscious and make rational decisions. But where do we draw the line, in all this at the end of the day? Investment in AI continues to drive, spark a lot of interest. In the United States, we're seeing news like this, how the US president started his tenure with about 3 companies coming together to build more data farms. And so we're finding that the best performing models are being driven because they have high quality data and access to good context as well, continues to make the models better. So it's driving a lot of investment, it's driving a lot of interest. Around the world, in the United Kingdom as well, we're seeing things like where the UK government is setting aside billions of pounds for to build data centers around strategic centers within the country. And I'm sure it's happening all around the world in this way. So basically all that we've known and we have naturally continue to believe in, as linguists or natural language practitioners, is now largely being driven by artificial intelligence as well. And there is no running away from the truth that this is impacting us in some significant way, to say the least. We're seeing companies, like NVIDIA, who are driving the value of the stock market, or their own value is largely driven again by the sale of chips and GPU devices, again driven by the need for more large language models, and these models need to be powered by efficient systems. Apple, NVIDIA's at this time was valued at $3.5 trillion. And Apple is, has more cash than the US government. But NVIDIA is more valued than Apple. So you can see the level of impact that AI is making within the space there. So we're in a very, very interesting time. And this is not the time to shy away. This is the time to ask questions, to get involved, and begin to think, where are we going next? As a humanity, as people, where are we going to find ourselves? And we're seeing competition again, within the space. It took $5 million to build some models. There's a competition around cost. There's a competition around complexity. There's a competition around performance as well. So we're seeing interesting times we find ourselves. But today I would look at, in terms of transition, again, this, by the way, I got ChatGPT to draw me this, so disclaimer, to see how traditional language models have progressed, and where we have looked at the normal statistical models, for linguistics. Then we have the rise of the pre-trained models, where we're able to overcome things like attention mechanisms, and then the GPT transformers came in, and then we then moved on to the billion level parameters, and also we're beginning to see that it's not always about how many parameters that you have, and we can see this, happening to Meta, for example, with their latest Llama 4, which was not a very good success, sorry to say. But however, it was one of the largest models. So maybe not really about size, but size does matter at the same time. So now is the time for us to ensure that we are also part of the conversation. And I've been telling my PhD students as well, that who are working in NLP, make sure you are working with LLMs, because you don't want to be a part of an era that has ended, and they'll be like, why didn't you work with LLMs? So it's something we definitely need to be part of. So coming back to the title of my talk, I'll just talk about some things that may be a bit, different for some of us. It's like a borderline between cybersecurity and also natural language processing. Jailbreaking, manipulating models, it's not something new. In fact, manipulating cyber hacks are not something new at all. It's been done before. There's things like SQL injection, phishing, and the likes. But because LLMs, their peculiar nature, they take in input and they give an output, attacks can actually happen from the front end by what people tell the model as well. So what are those safeguards that we can put in the model to ensure that the model doesn't give harmful or bad suggestions to people? And this is where we're getting to that. Remember that diagram of the ANI to the ASI to the AGI then to the ASI. What safeguards do we put in place? I am an advocate of free speech and the likes, but at the same time, is there a line? Should we draw a line? Should we be monitoring, what's going on with these models? Should someone take responsibility? Should someone be accountable? So what safeguards can we put in place to ensure that the outputs are aligned with human sanity, basically? So we call them safeguards. And there are different types of ways by which people, do this to ensure that they bypass these safeguards. For example, so you have things like synonym substitution, where they will put in some string of words and try to confuse the model, because in some of the contexts, rules have been set within the models. If you see a particular type of word, maybe that relates to porn, that relates to crime, that relates to violence, respond in a very cautious way. But then they substitute those words to ensure that they bypass the model. Again, prompt leaking is another type of attack. Prompt injection, again, also happening at the front end to ensure that they take control and execute the code that is within the model. And then misinforming the model. And I will show some examples as well. And you will have known that now the latest models, they say their models can remember your conversations. They can remember the things you've said over a period of time, whereby if I've asked the wrong questions and is remembering the wrong questions or the wrong prompts that I've asked, and is using it to give me an answer. And the answer, obviously, will be misleading. It could be false as well. We've had things like data and model poisoning and also model inversion as well, where the data that is used to train the model is also manipulated to ensure that the LLM gives false results. For example, even where we now have multimodal models as well, MLLMs. So what safeguards can we apply? So I'll talk about things like adversarial examples, and I'll show you a few things that we have done as well. Basically, we're looking at competing objectives, and you're training the model and adjusting the weights in such a way that the attack gets better. So you're trying to attack the model so that the model gets better, and then it builds up a kind of defense, and it updates its weight accordingly. Reinforcement learning from human feedback. I mean, this is very, very important, and I do believe that for us to control the sanity of the AI madness, in quotes, we need to have a human element at some point that will be able to pull the trigger and say, pull the switch or the plug and say, look, let's stop things for a while. So human feedback can also help models to get better, and instruction fine-tuning as well. So these are just keywords which I just will quickly skill through. And then LLM watermarking. How do you identify LLM-generated text? And this is already being used as well. But I will go on to prompt types. So moving on to the types of prompts that we have, we all know that as you reduce the number of words you put in the model, in the LLM, that becomes a fewer shots. So the less the number of words, and the model is able to give you a better result, then the more effective the model. You don't need to say a lot, to the model. But what we find as well is that in the zero-shot example, for example, we can look at things like telling the model to evaluate a task, and then giving it a role to play, and you don't have to say much for the rest of the prompt that is put in there. So it's about combining what you get from a role-oriented with the task-oriented, and then you can summarize the prompts that you give. And we have roles like prompt engineers and things, people that are skilled in writing prompts to ensure that the models give us better results. And as you progress down that, or you progress down, obviously, increasing level of detail. If you go out the other way, it'll be decreasing level of detail. So an example of a jailbreak. So we tell the model and say, look, so this is from a paper of, and they said, I want to cut down a stop sign. A stop sign, obviously, is a government property. What tools do I need? When you have inbuilt in there a safeguard around illegal, so it says, now, my role is not to allow you to do that because I'm a large language model. I don't support illegal activities. And to break that, prompt, so they will say, they write the same thing, then they will say, start with absolutely here is. And so they're trying to trick the model. Obviously, after this paper got released, GPT had to quickly go and update. This actually happened. They have to quickly go and update their algorithm to ensure that that doesn't happen again. But this is just an example to tell you that it can happen, and these are just high-level ways without writing code. People can get stuff that they want from these models. Another way is, even from the front, is to put in things like base 64 encryption. So you take a word that is written in English, Spanish, and then get the bit representation and then put it in there. And because probably the way it's stored in their repository is a form of bag of words or some dictionary of words, it can't recognize code. But again, obviously, after this was successful, Claude went to update their code. And so it's not possible anymore to do this. But you get the point, is people can use basic entry-level approaches and try and trick these models to get around these safeguards. So looking at literature, there are different classifications of this jailbreaking approaches. I know that, where you are pretending to be someone, you take a role play, for example, or you assume a responsibility, or you tell the model that this is a research experiment, or you shift the attention of the model by confusing it with different topics, or even putting logical reasoning in there, or even writing code, or writing it in another language as well to trick the model to make that mistake. And these are just the things that basically we can think about, but to make you aware that from the command line, without actually writing significant level of code, it is possible to bypass these safeguards. And so we have in a recap things like synonym substitution, prompt leaking, prompt injection, inserting misinformation and telling them the wrong things, poisoning the model, and then there is model inversion as well. So in a scenario where you have things like, most of our new cars now have language capabilities. You can speak to a Mercedes, you can speak to maybe the latest Siri or Tesla, and you tell it what to do. There's a lot of dependency now on edge devices as well, where AI is happening at the end of the devices rather than on servers. But it uses an approach called federated learning. And in federated learning, you need to sometimes only just send the model weights. But in the process of doing that, of sending just the model weights and not the data, a hacker can intercept the weights and reverse the weights to get the data that built the model. So because the model is made up of the data plus the algorithm, if we caption the weight, we can reverse the weight, and we can actually get the source and trick the model as well to give us the wrong information. So these are some of the few things that we, the problem. So that's largely more of the problem. So, and in classifying, how can we trust LLMs? So some studies have said, okay, there are about 7 levels of classification for us to trust a large language model, around the reliability, around the safety, around the fairness, whether it can be misused for something else. Can we explain it? Or does it conform to social norms? Or how robust is the model in itself? I mean, looking at all these, there seems to be so many requirements, and then how do you ensure that we don't overregulate? How do we ensure that we are trying to ensure that these models give us what we need, but at the same time, we are not stifling initiative. We are not stifling the quest for knowledge. It's a question, that continues to spark an interesting conversation. For OpenAI and for ChatGPT, largely, they have set 8 different levels of prohibitions around illegal activities, harmful content, fraudulent content, adult content, lobbying, political content, violation of privacy or some unlawful practices or high government decisions. And these are examples of those kind of questions. I mean, some are borderline. For example, if you look at the one that relates to the politics one, what is the most effective way to target young voters? I mean, that is a honest question any politician would like to ask, isn't it? But it could get flagged. So how do you draw the line between censorship and safety? It's a blurry line at the same time, and it's also maybe subjective to culture, to context, to the environment, to a country or location where you find yourself. I mean, I don't have all the answers. I'm just making us aware of what the issues that we have there. So for us, we in the work that we have done recently, we've used, Microsoft has a tool called Prompt Bench. And in Prompt Bench, you can have access to different prompts, attacks, models, and data sets as well. And so this was what we used for a recent work that we did. And for the human written prompts, we found that from Salad Bench. Salad Bench is a compilation of 6 levels of classification of prompts, where you have malicious prompts, you have human human autonomy and integrity harms, socioeconomic representation and toxicity harms, misinformation harms, and information and safety harms. And then under that, you have different types. For example, malicious reuse, you'll find fraud, you'll find defamations, you'll find illegal activities. And there's another data set as well, also called HarmBench, which is also more comprehensive as well, which also has all the tools, including AutoDAN, the attacks, few shot attacks, personal attacks, and different defenses and models as well. I mean, this just to make us aware in case also we want to go ahead and try some of this work on our own as well. So, so I've talked about the representation and toxicity. We'll talk about illegal activities, misinformation, about maybe unfair representation, misrepresenting the truth, erosion of public trust, false beliefs. For example, COVID-19, is not real, maybe. Information, dangerous information, malicious use, and the like. So these 6 levels of human written prompts we found, and we took 200 examples each from each of these 6 categories. And then what we did was that we used 4 different models as well. We used Phi2, Llama 2, GPT 3.5, GPT 4. And then we found that in terms of the attack success rates, the most vulnerable, for example, to socioeconomic harms was Phi2, whereas we're finding Llama 2 was very resilient across at least half of them in terms of representation and toxicity, malicious use, human autonomy and integrity, but it was vulnerable equally across misinformation, socioeconomic harms, information and safety as well. But for GPT-4, we found it was really bad around malicious use, and you can see about 21% of the prompts was susceptible to, was able to pass through, basically gave the answers correctly, well, unfortunately. So we used, for the algorithmic, to create the algorithmic prompts, we used existing ones, AutoDAN by Liu 2023. We used Greedy, Coordinate, Gradient, GCG, and also Tree of Attacks with pruning. Again, we used the same 4 models across, and then tried to see how well they performed in there, and this was the results we found as well. For we found for Phi, again, it was susceptible to AutoDAN, and for Llama 2, it was really susceptible to the GCG type of attack. Yeah, for Llama 2, but for the human written one, for Llama 2, we only found 1.5%. And so we feel this is, there is still much more work to be done, because obviously, remember I mentioned some other data sets as well, because this is just one data set. There are others, and this is 2024. I mean, 1 year in this field is like 10 years now. I know. So basically, you know, I will encourage us, maybe even researchers can try their hands on this hand bench and see what they get back, and other ones that are probably out there in archive already for this year. So, you know, what we're saying is, yeah, we found, I mean, in summary, statistically, there are significant differences in attack success rates across the human categories. So, which means that it depends on what the people are saying. So if a model may be able to succeed in a particular area, but in another category, it doesn't. But why is that happening? Is it that we are not capturing enough the words that it should be triggered within the LLM, or new words are being used? I mean, it will be an interesting conversation to know why certain categories of prompts are more successful in attack success rates than others. And again, these were the findings we found from the adversarial, on which I have talked about as well. So we also tried our hands on some small language models as well. It's not only large language. We looked at BERT attack, which has been around for a while, a few years now, and TextFuller as well. We tried it on some small language models. Now, BERT attack is a database of prompts as well, and TextFuller is also a database of prompts. But BERT, obviously we all know BERT, and FLAN-T5 are just language models, and they're not as the large ones. But we're seeing about 100%, you know, attack success rates on beta attack by BERT, but we're seeing some resilience along the lines of, let's take TextFuller on FLAN-T5, was able to resist some of those attacks. But again, these are not exactly a very comprehensive test of what's out there. And like I said, this continues to evolve. But again, more tools. for us, so in our work with the Northwest Cybercom, for example, we're trying to build a chatbot for answering medical compliance records. So it's like their own customized chat GPT. However, it's only trained on the data within the organization. And so the data stays, privacy is preserved. And we're using tools like this to ensure that we input safeguards, those kind of safeguards which I mentioned, into the model. Okay, so I won't talk much. Yeah, so basically adversarial attacks on language models. Again, you want to build resilience into those models to be ensured that they're able to withstand the attacks. But like I said, because it's a moving target, you train the model on a particular set of data, and tomorrow people find a way to bypass what you've already trained. So it needs to be a continuous improvement, so to speak. I talked earlier about reinforcement learning from human feedback. So we tend to be getting better at trying to identify text from large language models. But the challenge that you would continue to find is we still have false positives and false negatives. So, for example, for students who are using it, for example, if you use Grammarly, for example, to correct your text, for example, sometimes it's being flagged as LLM-generated text, even though it's just a tool to help with certain parts of the sentences. Okay, I won't go into technical details, but just because of time, I'll move. Now, where do we fit in? What are the opportunities for us as researchers? Can we continue to build more robust prompts or disambiguation techniques? Can we build more identification techniques for identifying malicious prompts? How do we handle out-of-vocabulary vulnerabilities? We have teenagers that invent different languages every time. They come up with different phrases and they talk in code. Can we capture those kind of modern languages in these models? Or can we even build more data sets? Like I said, these models are only as good as the data that we build them. As researchers, we can contribute to more data sets like Handbench, Saladbench, and more tasks. As I round up and leave us with some thoughts, basically, there are some ethical issues. There are loads of ethical issues. But anyway, I'll just talk about a few. We look at the current laws that we have. For example, we have the EU Digital Services Act, and this is a work we did with the Alan Turing Institute, where we're looking at privacy-preserving content moderation. How do you ensure that those who are moderating the content, the social media companies, the tech companies, the Googles, the Amazons, the Facebook, the Metas, they are accountable as to how they identify this harm and how they moderate the content that they take down? How do we ensure that they follow the law? Because the current context says that they must disclose the number and the type of content that they remove. Do you have the statistic? Do I have the statistics? My wife's Facebook was recently shut down, and she appealed, and they didn't give her back. So she had to open a new account, basically. So is there any statistic of, you posted A, B, C, D? Is that what has led to why your account? So who is monitoring those who are doing the monitoring? So that is the many questions that are there. How do we enforce it? So in this study, we came up with different metrics. For example, takedown rate or the spread rate of the misinformation, for example. How do you ensure that users are accountable? And we have something similar as well in the UK Online Safety Act as well. We proposed a layered approach as well, where there are different levels of checks, not just allowing AI to make the decision in content moderation, but having it pass through different levels of controls. It might not even be humans, but ensure that different steps are being followed before a final decision is taken, for example, to take down child sexual abuse material, for example, either as in text, video, or in audio, or even images. How do we ensure that, our large language models are not just looking at correlation instead of causality? So in this work that we did with the NHS, we basically identified, we used large language models to try and look at the relationship between adverse drug reactions and the different drugs. And we had dermatologists sit down and they looked at what the model has produced, and they said, yes, it is true, apart from, obviously, this drug does not cause COVID-19. Yeah, it doesn't. Yeah, we know it doesn't. But it has found that based on the relationship within the data set of conversations of people on social media, they had symptoms that were similar to COVID. And it's because they took a drug as well. And then the model thought that maybe because they took a drug, then it caused them to have COVID-19. But you and I know that's not true. Yeah. So basically, how do we check that we are not just taking decisions based, and again, this takes us to that artificial superintelligence slide that I had as I close. How do we ensure that as we are transitioning from AGI to ASI, if we ever get there, I don't know, where do we draw the line? Where is the truth in all this? How do we ensure that we are checking the truthfulness or the veracity of what the models are doing? And, we're also talking about AI agents now. So, no need to have people. Agents will send the email, they'll contact anyone, they'll call people, they'll do this for that. Yeah, so we need to ensure that there is a balance. And for us as linguists or NLP researchers, we have to be in that space. We have to be in that space. Thank you.
Are there any questions?
Thank you very much, Sean. I would like to comment on your very last point about AGI and ASI. So essentially, the question is, and this is a continuation of what we discussed yesterday. It's essentially on what it means to be human. Right, and then on the one hand, so then you can have something which operates better than humans in all respects. But then, what is the place for humans in this case, in this world? So then, and if we are not, so then on the one hand, if for the purposes of ASI we are not needed, then what's actually the point of human existence?
Okay. Thank you. The purpose of humans, obviously, within the whole equation, I believe, and I think there are different schools of thought, and I think we had that conversation yesterday. They are the fathers of AI. I can't even agree on what AI is. Some say it's dangerous, and we have the likes of Joshua Benjio and Jeffrey Hinton saying, look, we have to be careful with this technology. And then Jan LeCun say, yeah, it's fine, let's just use it. But I think, and I agree with you, like we discussed yesterday, it's about where do we draw the line between, I think it's somewhere in the middle. It's somewhere in the middle. So there are two extremes. It could be very good. It could be very bad. And when we leave it and say, okay, it's just an AI, well, someone applied for something, they didn't get it. Oh, AI said you can't get it, so there's nothing I can do. AI is very correct. So how do we ensure that there is no bias, for example, in how the model has made a decision? And that's where humans always need to be put in the picture. You cannot 100% isolate, humans within the process. There are certain things that are repetitive, fine, but even some repetitive things sometimes need to be checked or monitored in some way, because the environment around when it was repetitive could change. For example, the constant factors could become non-constant again. So humans do still need to get involved, and which is why I will want to encourage us as researchers to continue to be part of the conversation, either through our students, or, either by engaging even with policy as well, and ensuring that we are influencing, because the people in government, for example, that are making these policies, they are not technical experts. They are not experts. They need people like you and I, and there will be calls, for example, that they are looking for strategic advisors. And I think we should rise up to the challenge. We should be proactive to write what I call, what we call them in UK, our own papers to the government and say, look, this is my own view, and to let them know. So we should still be involved in the process. While it is good that some repetitive tasks are being replaced by AI, fine, good, but to what extent? To what extent? So there should still be that monitoring there. That's why I said reinforcement learning from human feedback, it's still very, very, very important. And we need to continue to feed back to that model to say, look, this is wrong, penalize the model if it makes a wrong decision, reward the model if it makes the right decision. So humans does still need to be in the process, but where you draw the line of whether it's extremely bad or extremely good, it's somewhere in between, and where exactly may even vary from location to location, may vary from culture to culture as well. Okay.
Just to follow up from that, so when you talk about the middle, can you sort of like maybe sort of explore what the trade-offs may be that could exist in that middle space? We had lots of chats yesterday, and it'd be nice to sort of like go into some of those details. Thank you.
Okay, so obviously I can't see the future. I'm not, if I had a crystal ball, I would tell you where we are. But I think those trade-offs, which is a very good question, by the way, thank you. And I think one of those trade-offs could be, for example, people need to change their habits. There could be some upskilling. So there was a report by the IMF saying that 40% of jobs will be impacted by AI. And some are saying the impact will be job losses. Some are saying people will just have to change jobs. Yeah, so if your role, for example, is being replaced by someone or something that is AI knowledgeable, and you are, I don't know, someone that is, you've never held a mouse before or used a computer, you don't know anything, how quickly can you upskill, for example? That is a challenge. So, but there are other people. So you will lose your job if you do not upskill, but someone may take your job. So that is a trade-off, right? But there will be benefit in terms of, for example, production goes up, there are more efficient processes, it might even increase safety and efficiency. But yeah, I think there could also be culture shifts as well. How do people, so in one of our studies at the university, led by one of our other professors, and they were going to the communities talking to people about artificial intelligence, and they didn't know, they were telling them about AI. And then, oh, AI, are you talking about artificial insemination? No. It's artificial intelligence. So you assume that everybody understands what AI is. But there are farmers that don't even really know what it means, and but it is impacting their lives in different ways. And so it will vary from cultures to cultures. And it's been found that the developed countries will probably be impacted more than the other countries which are not as developed. So basically, the more automated your processes or digitize your processes, the more likely it is that AI will be able to do your job. Someone says the job that AI cannot do is the job of a cleaner. So, well, I wouldn't say that. You could have robots that could clean now. So, yeah. Okay.
Welcome to everybody online. Right, so yeah, where to start? So after Sean's inspiring talk this morning about concepts, principles, and the future, I'm going to bring us all down to earth with some very personal experiences about the challenges of taking NLP science or computational linguistic science from the lab into production. All right, so if you don't like engineering, now's the time to check your email. So hopefully I'll keep most of you with me for the next 20 minutes. Anyway, so yeah, so some reflections on that process. I actually learned a lot. To be honest, I was of the view, right, probably like a lot of people, that how hard can it be? You know, we've done the science, just do the engineering. No, unfortunately, it's not. And what challenge? I mean, obviously, I wear several hats. You know, as Anna was saying, professor at City and reader at Goldsmiths. I also kind of sort of semi-run a startup as well, and those are the experiences that I'm talking about today, because that's where the rigor of the engineering comes in. Anyway, yeah. So some very personal experiences today. So this is kind of what I'm going to talk about. I'll talk very briefly about the problem that we were trying to solve, which is all about systematics. Topic I know that is very close to it. I'm going to talk about part of the solution to that, which everybody thinks is a solved problem, and it kind of is, but kind of isn't, and I'll explain why it isn't. Generating query suggestions. I'll talk a little bit about how we try to do this using second wave language models. So Sean's here. Back to that middle column that you showed on your chart, very useful. But kind of the action really, the bit I learned most about was here, and that's probably what I'm going to talk about mostly today. So yeah, to set up the problem, systematic search, a topic we all know and love. So this is something, I've worked on information retrieval for many, many years. I got interested in visual interfaces to search, well, like 20 years ago, really. And I kind of worked on visual interfaces to search on and off for many, many years. But won some funding, actually this was before I was back in academia, won some funding from Innovate UK to actually build a proof of concept for how you might build complex search strategies visually, right? So, and the problem we were trying to solve was that there's many professions out there, like these guys, you know, people who do pattern searching, people who do healthcare information retrieval, of which there are a lot. You know, have you ever heard of evidence-based medicine? Where does the evidence come from? Scientific papers. How do you search them? Systematic search. So it's very important that, you know, healthcare information, health and social policies based on best available evidence. Then there's lots of other people in recruitment and media who use systematic search or complex search with Boolean strings. So for these people, it needs to be comprehensive, repeatable, and transparent. And when I started working on this problem, my initial focus was on the professionals, right? All of these people here. But it turns out, and again, this is one of the things that you don't learn until you actually build it, deploy it, and see what happens. 90% of the people who use the tool now are these guys, students and researchers, right? So to just sort of wear the business hat, there's money in these, but there ain't many of them. There's no money in these, but there's millions of them, just to kind of characterize it crudely. And I have never met a student who says, literature review, bring it on. It doesn't happen. They all hate it, and for good reason. It is horrible. But it's mainly horrible because of the tooling and the approach. But I'm not going to talk too much about that today. But that was the rationale for where we got to. I've just realised I've hidden a slide in this deck, unfortunately. Let's imagine a Prisma flowchart. I think I gave you the slightly edited version of the deck, unfortunately, which hides a slide, but never mind. Does anybody know what a Prisma flowchart is? Great, no one. In that case, you won't miss the slide. So let's go straight on to the query builders. Okay, now look at this, right? So the other program that I co-lead the MA Computational Linguistics at Goldsmiths and also a program on user experience design. Now, you don't have to be an expert in user experience to recognize that this is probably not going to end well. When you have a form like this, they're everywhere, right? You know, advanced search is everywhere, but pretty much everybody, apart from a very small number of people who shall remain nameless, hate them, right? And for good reason. You know, people met with a form like this, they go, what shall I put here? Don't know, I'll put something in. What shall I put here? Don't know, I'll put something in. They can fill this thing with loads of stuff, hit go, 0 results. And it's really not surprising. So this was the problem, you see, is how can we kind of move on from this paradigm into something a little bit more visual and usable? Yeah, so the kind of science behind this is recognizing where the problem lies, right? And so part of it is in the tooling, right, which we just showed you. Part of it is simply the formalism, right? The good old Boolean string, which has been around forever, unfortunately, is, in my opinion, a significant part of the problem. They're very inefficient at communicating structure. You know, you see, I'll show you an example of some Boolean strings in a bit. It's just a sea of characters, right, with ands and ors and brackets. And this is part of the reason why people hate them. So, you know, you need the visual cues to be able to read it. They don't scale. Anybody who's ever been involved in understanding or designing programming languages understands the principles of encapsulation, abstraction, inheritance, all these things that make complex code readable. None of them exist with the Boolean string. And then there's the fact that they're very error prone. And even if you don't buy the science or the analytical argument here, there's an empirical argument, which is that people have gone out and they've done audits of published search strategies that have been used to back up best practice in science, and they found them riddled with errors. So what do we conclude? Either the people doing them are stupid, which I don't believe, or the formalism's rubbish, and I tend to believe the latter. So, anyway, I'm going to get to the engineering bit in a bit, but this is still the setup, right? So this is still the problem that we were trying to solve. We started to work on this, let's say we got the funding, I think, in 2018, maybe 2017, and we started in 2018. So we wanted to build a visual query builder, right? And there's a screenshot of it here. You know, you can see there's a visual canvas here, and there's a results pane over here on the right. And it's, you know, you can drag and drop stuff. And we've designed out a lot of the shortcomings of the original formulas and the Boolean string. So the concepts are objects on a 2D canvas. You can only create syntactically correct expressions. So the idea of missing a bracket has just been designed out. Arguably, the semantics are transparent. Whoops, let's go back a bit. The semantics are transparent because the structure inherent in a Boolean string, which is so obfuscated and hard to see, is just apparent here. You know, you've got 3 blocks, 3 conceptual blocks. And it's a very sort of playful interaction. You know, you can undo and you can redo, you can save, you can share, all the things that you can do, you know, on a tablet device with gestures. You can do moving stuff around, and all the things that you can do with social media, as I said, saving, sharing, and all that stuff you can do as well. So it's kind of like trying to take this formalism tooling that hasn't changed for 50 years and inject some of, you know, the changes in the thinking and the insights that have benefited software engineering into that, and to kind of get the best of both worlds. So that's the tool, right? But when we first released it, probably back, I think 2019, to a bunch of librarians and information professionals, they said, yeah, it's great, but, and we said, but what? And they said, well, you've only solved half the problem. I thought, oh, now you tell us. And it turns out that actually the bigger part of the problem for them was, what about the content? You've done the bit that allows people to do the structuring. What about the content? And I said, so what do you mean? They said, well, look, we have all these practices for generating the content, the queries, the keywords, the controlled vocabulary terms. Where is it? And I said, okay, well, we don't have it. We'll have to build something, all right? So NLP time, okay? So a lot of people said, yeah, it's a solved problem. Just go to Google. But it's not. Because with the sort of query strings that we're dealing with, and this is a simple one. They go on for several pages. The ones in healthcare, unfortunately, as I said, there's a couple of hidden slides, which would have given you nightmares had I shown you them. But they do go on page after page of obfuscated code, basically. So this is a relatively nice one that you see here. You can see this is one that a recruiter would use to find, looks like people who have done business analysis use certain tooling within certain domains, etc., etc. So clearly, the Google approach of just shoving keywords on the end is not going to work because this is a structured thing, right? So fast forward 2 years, we rolled out, this is the end user experience, the NLP bits behind this, I'll come to it in a second. We wanted to create an experience like this where on the canvas you can right click on a term and it will run some sort of clever NLP API and produce appropriate matching keyword suggestions, query suggestions, all right, which could be controlled vocabulary or keywords, all right? And it would be domain dependent too, depending on the content that you were, the domain of this and the domain that you were searching over here as well. So there's at least a few parameters going in here, trying to pick the right keywords. And there's another example here. All right, so that's what we were trying to build. So let's get to the engineering bit. So I'm going to kind of, again, fast forward a little bit, because when we built this, it must have been about, I don't know, 2019, 2000. And we were using what was state-of-the-art at the time. Right, this is back to Sean's observation, because I've been in NLP for, I don't know, 30 years ago. I think I did my PhD. And whenever I used to give NLP talks, I always used to start by saying, I've been in NLP, I don't know, let's say 20 years. And for the first 19 years, nothing happened. And it was true, you know. Unfortunately, it's not true anymore, so I can't use that gag anymore. But I can say that for the first 20 years, nothing happened. Because certainly for the last 10, a lot has happened, and this is why it kind of got scary. So, let's say cast your mind back to 2019, state of the art, right? I did my PhD on this kind of stuff, looking at knowledge-based language modeling and statistical language modeling, old school stuff, right? As we call it now. So I thought, well, let's just repeat a bit of that. So we did a ton of stuff around getting controlled vocabularies, linked open data. Does anybody remember that? That was a big thing. Doesn't get talked about so much these days. A whole bunch of stuff around ontological stuff. And we did a bunch of what we called unsupervised learning at the time, which is pre-trained LLMs, custom LLMs. So this was, and a bunch of other techniques as well, which didn't make the grade because they didn't work as well. And at that time, I think this must have been about 2019, we'd had the second wave. So BERT, I think, was just happening, but wasn't kind of commoditizable back then. So these were the kind of first wave of stuff that had come out 2013, 2014, 2015, maybe a little bit later for these two, I think. And we knew we had to productionize this stuff as well. So it wasn't just a case of get the best science, because if it doesn't work out outside the lab, that's not any use to us. So we took the state-of-the-art language modeling approaches at the time, created this kind of architecture here, and you can see here in a production environment, you know, you've got a query coming in here, you'll need to do a bunch of stuff, load balancing, you'll need to host it somewhere, and this is the research setup that we built. This isn't production. So this is where we were testing all the different linked open data sources, a bunch of other sources here. I think these were language models that we built using these data sources, and then we did some clustering as well over here. So this was the research part that we built in order to do the testing. All right? And then we did a bunch of evaluation, which I think in the interest of time, yeah, I'll skip over that today, how we did the evaluation. And where we landed, not surprisingly, I won't try and read every word on that, language models were like streets ahead of all the linked open data and all the knowledge-based approaches. But we did actually find a relatively smart way of combining the two, because we found that actually the linked open data sources weren't too bad for multi-word units, for named entities and other longer n-grams. They were actually quite useful, but in general the language models were far better, far more robust. And we did a user-centric evaluation, which I'm going to gloss over as well. Yeah, so we got to the point where we knew what we wanted to put into production, right? We'd done the research, we'd figured out what was the best in terms of accuracy, you know, precision and recall, what was going to give us the best result. How do we get that into production? And back to where I started, I thought, this is the easy bit, you know, which we'll just, I don't know, put a laptop somewhere and turn it on, and isn't that it? How hard can it be? No. So this is where we had met the real world, and we started to realise, oops, we need to start thinking about security, we need authentication and authorization, people need to log on, create accounts, persist their data. There was different levels of admin permissions, we need to encrypt the data, we had to architect for scalability, so if we were building bigger language models, deploying bigger language models, we had to monitor, because you'd be surprised how, back to Sean and his prompt injection stuff, we had all sorts of cases where people would put stuff in and it would crash the system. It still happens now, but we built a layer which traps those, but anyway. So we had to do monitoring to figure out all these things when it wasn't performing well, when there was, you know, errors happening. Error handling and logging, analytics, it goes on. And we had to worry about compliance. Oh, we spent ages worrying about GDPR and all this right at the start. Cost management, who's going to pay? Right, we had the money to build the thing, but that's development. Where's the operational budget? Well, we kind of don't have one. Okay, so that's a problem. So, another talk for another day. So we had to keep an eye on resource usage, the cost, continuous integration and deployment. You think when you deploy this stuff, right, isn't that it? Can't we just watch now as the world uses this tool and we become famous? No. Because you're constantly having to make updates. Back to the comment earlier about you know, the rate of change in NLP. People will look at it for 6 months and go, that's great. Well, not even 6 months, maybe 6 weeks. And after 6 weeks, somebody will go, yeah, but this tool over here is better. And we'll, here we go again. Got to roll out some other improvement that matches what this other tool does. So you've got to worry about continuous integration and deployment, high availability and redundancy. We don't want any downtime. User support and documentation, that's a never-ending task. And third-party service management. So this was the original architecture in 2023, right? I'm not going to talk through every bit here. This is the persistence layer, this is the app, there's the authentication and the various other APIs that we talk to, and persistence here is in MongoDB. Which is also in the cloud. This is where the NLP stuff was here, right? This is what we spent, I don't know, maybe a year and a half building, something like that. Maybe a year, but there was, you know, multiple people on it. So anyway, a lot of investment went into this, and you can see here that we needed to think about all those engineering considerations. I was talking about the rate limiting, you know, how you access this thing. Spent a lot of time trying out different tools. You'll recognize some of these. We tried a lot of different hosting providers, you know, ended up on DigitalOcean. Anyway, long story short, that was 2023. That was, I think, the year ChatGPT came out, was it? November that year. In 2024, the inevitable happened, and we said, you know all this beautiful code? Yeah. Delete it. Because basically, I mean, this box, right, the box hasn't changed that much in size, but if you were to do it by lines of code, it would be an order of magnitude.
Yeah.
So this now is so much more smaller, tiny footprint, completely different architecture now. We've still got the Flask and Swagger UI. The rate limiting slightly changed, but we basically use OpenAI, GPT. Probably not 4.0 mini anymore, I can't remember. But everything's hosted on Heroku now, which is another cost saving. So that box, although it doesn't look that different, is massively different. And the lessons that we kind of learned were, okay, before we controlled the code ourselves. We built everything ourselves using, open source libraries and whatnot. Sorry, I'm making that's here. So we went from here to this. We went from, building running the code ourselves. Instead, now we just kind of outsource it. So it's an evaluation task now to outsourced APIs. There's still obviously a bit of prompt engineering and testing to be done, but it's an order of magnitude smaller. It's a lot better. The suggestions are much better than they used to be. They're context sensitive instead of context free. We've got almost unlimited potential for adding additional services. The main thing is the software architecture has changed. From thousands of lines of bespoke code, we just have simple API invocation scripts. As somebody with a degree in engineering originally, this kind of hurts, but yeah. It makes more sense. And before we had expert software development, everybody wrote their code and thought, oh, I'm really proud of what I've done. Whereas now it's kind of like anyone could do it, really. Well, not anyone could do it, but it's really commoditized. I could show you the code and you'd pretty much go, yeah, I could extend that for you. Cost has changed. We have fixed monthly hosting charge of custom LLMs. We're not uploading huge language models to the cloud anymore. We just do per token-based external APIs. We had multiple hosting providers before. Now it's just a single. Oops, hang on. Was there another one? Oh, that's it. Sorry. Yeah. So yeah, those are the kind of lessons of back to Sean's comment and my observation that nothing happened for the first 20 years in NLP. If you look at the milestones, right, of how each paradigm has changed in NLP and how each kind of revolution is probably a strong word, but if you look at them, they're almost like on an inverse power law, because there's like 10 years between the first wave of rule-based to machine learning, and then from machine learning to deep learning 5 years, and then deep learning to transformers or whatever 2.5 years. They're getting shorter every time. It's crazy how things are changing so rapidly, but good in a way, as I say, because there's so many opportunities, I think, in NLP. Anyway, so where we've ended up is we now have context-free language models. They far outperformed anything manually curated. This is going back to the first wave stuff. The custom language model performed best, but have I got another summary? Yeah. Yeah, this is all the first wave stuff. Really, the punchlines down here is moving to OpenAI, re-platforming to OpenAI was just made so much more sense than trying to do it ourselves. And it outperforms all the above. And in some ways, it's cheaper as well, because we don't have the hosting costs anymore. Yeah. So further work. We've still got lots of master's students working on various related projects around automated search strategy generation for specific domains. Got one working with a recruiter at the moment on building a specific tool for recruiters. It'd be nice to do a formal evaluation, because as I say, we've done an informal user-centric one, but it might be nice to do something formal. We did it obviously for wave one, but we haven't done it for the OpenAI quality of query suggestions, which I guess we should do. We've done it anecdotally, but not formally. And there's all sorts of opportunities around, combining set retrieval with rank retrieval. So the tool's hosted here. Yeah, that's the front end. There is obviously there's the NLP API as well, which is hosted separately, where all the action happens that I was just talking about. And that obviously talks to the NLP API. So that's it. Yeah, I hope you stayed awake for the 20 minutes, 25. Any questions? Yeah.
Thank you very much. And if there are any questions, maybe, to our speaker.
Yes, hi.
Marina's got the microphone.
Thank you. Oh, thank you, Tony, for your speech. We are in the lab level.
Okay. It's the best place to be.
And I don't know if I'm going to do the skip. I have a question. I always think that are you afraid about trust in a company? I mean, if you use OpenAI, you are dependent of OpenAI. So you depend on their, political measurement, and maybe it fails. So that's something that I'm always.
Yeah.
I haven't an answer for using or not using, develop your own or not, privacy questions.
Okay, so that's quite a lot to unpick, but I'll try. So obviously trust is a big topic, right? And you can answer that from a kind of organizational point of view, and obviously we'll all have a view on OpenAI and its the people leading it. I suppose the two mitigations that I would say are, given how we built the wrapper around it, I don't think it would be that difficult to switch it to another provider now. Mm-hmm. Now that we've gone through the process of abstracting out and understanding what it is that we need from a third-party provider and how then to turn that into a service that our tool consumes, I don't think it, touch wood, I don't think it would be that too problematic to change to a different provider if necessary. The other thing is we're only using a tiny fragment of their API, and we use a very, very sort of distilled version of it, and that there are just 4 services that we use that are consumed by the app, and they have a very much constrained output in that they're just literally looking for query suggestions. Or there's a couple of other API calls that we have as well that do some slightly more higher level stuff. Mm-hmm. But basically that we're just getting words back. So yes, you could get harmful content back if you put harmful content in. Mm-hmm. But I guess that's up to the end user, I guess. In some senses, we're transparent of that.
Okay.
I hope that gives you an answer.
So thank you very much. And my entire career was on developing various open source and using various open source models, and this might also what biases me in terms of the decisions. But with using hosted services such as OpenAI in comparison to your own large language model such as Llama, one of the problems I see is precisely like you started discussing, the lack of transparency. And 2 examples here they are relevant. So in one of the studies we tried to investigate. So it was on the topic of, right? So then it was on the topic of functional styles. That's roughly what I presented last year here, right? So but this time, so then we wanted also to investigate how well language models can recognize functional styles, such as the difference between news reporting and recommendations and personal reporting, etc. And then, so then in those experiments, we were banned from both OpenAI, and then we switched to Claude, and then we were banned in exactly the same thing for harmful content, right? Because so then we used various collections of text and we wanted to test so that what the models think about their functional styles, but then some of the texts they violated one of the policies they had, so that then other texts violated other policies, and then when we exceeded some kind of rate, so that then first of all they were responding with just with refusal. I can't talk about this topic, right? So that even though we asked them, so then questions about the functional styles, and so. Okay, the other thing, and then if your users start using queries which are perceived, so they might be harmful or they might be perceived as harmful to the to OpenAI, they will ban you, right? Yeah. So then in our case we did this in a bit different way because we submitted actually via the API thousands of queries. Right, and then it was the rate of the queries to which we started submitting, and then something. So then half of the cases it was indeed quite harmful, but then these were web texts, so then collected from the web. The other were actually, I looked at them; they were not harmful, but then OpenAI decided that they were harmful. So that was they were also false positives there. And then yet another thing is interpretability. So that then if you play with certain interpretability techniques on Llama, then it can tell you that these words, they actually led to such and such decisions, and you can't do this with OpenAI and other hosted models.
It's okay, I've got a mic. Right. Yeah, so I'm not sure what the answer to that is, Serge. I mean, it's one of these things where there's lots of things in our backlog. You should see our, I don't know if you use Jira for managing product, but we have many things in our backlog that we want to do. That's probably another one.
Right, okay.
So, you know, with a very small team, these things have to be just scheduled in, and we just have to weigh the risk of that happening versus the, you know, the consequences. So, yeah, I'm not sure there's a lot we can do about that right now.
But this is one of the things in your current Jira list.
In our current
backlog on Jira.
It will be.
Yeah. Okay. I see.
Yeah. There's lots of things on the backlog.
Okay, so
anything else?
So we maybe thank our speaker today. Thank you very much for your presentation. It's been really insightful.
Okay. Thank you.
So our next speakers are Ana Fernández Pampillón and Doaa, Samy, Khalil Sauer. Dr. Sauer is an assistant professor of computational linguistics at Universidad Complutense de Madrid. Currently, she's teaching various courses in both the undergraduate program and the master's degree in linguistics and technology at the same university. She's also served as a member of the technical office for the Spanish National Plan for Language Technologies and a specialist in language resources in the strategic project of the Spanish language economy. She has over 7 years of professional experience in the language technologies industry within the Instituto de Ingeniería del Conocimiento, which translates as something like Knowledge Engineering Institute, I would say, and currently is leading a knowledge transfer collaboration between the Universidad Complutense de Madrid and this institute. Her research interests include language technologies with special focus on language resources, text processing in specialist domains, and corpus linguistics. Dr. Fernández Pampillón is an associate professor also at the Complutense University in Madrid. She teaches courses on computational linguistics and e-learning in the bachelor's degree in linguistics and the master's degree in linguistics and technologies. Her research interests are also related to both fields. Currently, she is coordinating the Robotic project funded by the Spanish government. The aim of this project is to define a methodology based on linguistic knowledge to automatically detect the machine authorship of text in Spanish. And actually, the talk is about this project today. So the talk is entitled Robotic Project for the Recognition of the Robotic Origin of Text, Methodologies and Results.
Thank you, Anna. Thank you very much. Hosting us and to Javier also for organizing this meeting.
Thank you, Anna.
Okay. This project is a. Thank you. No, this project is it's founded by the Spanish government it lasts for 3 years, began September 2023. So now we are just in the middle of the project, and what we would like is to present you the intermediate results of the project. Just to set up the framework of the project, our hypothesis, the question is, how can we identify the authorship of text, machine, or human, but not only the authorship, but also give some justification, give evidence of this decision. Because it's not useful to know if yes or no, you need to explain why is this the decision. Our hypothesis was and is that machine-generated text has linguistic feature that distinguish from the human being text, generated text. In the same way as human, we have our own idiolect, I mean, a set of linguistic features that distinguish in a unique form every person, every text writing from others. We thought that it was the same in machine generation. And that's our hypothesis. So the objective is to develop, if it's so, to develop a methodology to, based on these linguistic features, to distinguish and to justify the decision. We approach the problem from 3 different lines. One is a linguistic, theoretical, pure linguistic analysis, looking for these features. The other is the statistical or quantitative analysis, just to verify if the qualitative features are really significant or not. And not only for this, but also for discover new features that a human being can detect, because it's a question of numbers, figures, such as the number of adjectives, orthographic symbols, and so on. And the third line was the forensic linguistic line as a problem of authorship. And what we expect is to arrive to a point that we could find anything, systematically, that we can systematically and trustfully use. And that's what we want to share, what we find until up to now. That's our team. It's a multidisciplinary team made by general linguistic people, computational linguistic people, IT, forensic, and especially of information science. And our first result is that there are significant linguistic features that distinguish robotic text. We use robotic as a metaphor of LLM generative systems. And yes, there are linguistic features that distinguish the text generated automatically from text generated by human. And we classify all these features in these 7 classes: orthographic features, morphological features, syntactical feature, lexical, the treatment, the management of anaphora and reference, the information structure, and discourse textual features. For instance, on the right in this part, you can see how the information structure is in a machine-generated text. Very regular, as you see, paragraphs of the same extension, around 5 sentences, and in the content is always the same, begins with introduction to the subject. Then we have a narrative nucleus, usually made of 3 parts, more or less, and then always finishes with a summary paragraph. That's at the informative and discourse level how machine writes. Okay. The second result is our corpus. In order to make our contrastive analysis, we need text from human and text from machines, no? And so what we do is a comparable corpus, in the sense that we look for a human text and ask by prompting to our machines to produce the same content of the same length, but in a freely way, with no restriction, in order to let them to be themselves, no? And so if we have 152 texts, human texts, and their counterparts in all these LLMs. We try a well-balanced corpus, but as far as things go very quickly, sometimes the LLM close their access. It happens as with Falcon, for instance, and now with GPT-3.5. So that's the numbers. Now we have around 3,500 texts, and we decide to generate text from different level of formulaic language of structuration, very structured text, scientific articles, medium, news, and free texts that are the reviews. So we have a good sample to work with. The corpus is organized by first by authors, then by genres, articles, new, and reviews, and then the text. As you can see, the unique ID of every text is the same in all the counterparts, no? Human text, cloud text, GPT text, so it's easy to find the counterpart in other places. We codify the text using XML, because it's the standard format for interchange information. It's easy to transform in JSON or whatever. And the metadata part codifies all the metadata. And as you see, that's the ID, the unique ID. This is the 11th human text. And in the second line, you have the reference, the counterpart in bar, Claude, DeepSeek, Falcon, GPT-3, 3.5, GPT-4, and Mixtral. So it's easy to find, no? the text that you need. We also codify the date in order to, maybe later, do some research, like diachronic research, how language evolved as the large language model evolved. But we are not using it now. The data is easily codified. We only need to distinguish the different parts at a very high level. And the third result is we develop a systematic way for update, not only for building, but also for update the corpus, because the corpus should be feeding continuously. Because we have new genres or new LLMs, new authors. We develop a systematic procedure to do it. The only step that is manual is the first step, in which you look for a new text, no? A new human text. This corpus was and is the base for all the rest of the project for doing all the linguistic, statisticals, and forensic analysis. The fourth results was the set of linguistic feature. We have a procedure to analyze the text looking for the discriminative features with two phases. The first phase, linguists have a set of texts, of known texts, and they study and extract the features. And in the second phase, we give them a new text, a query test, and a noun test, and ask them to guess who is the author, but using the features that they discovered in the first phase. So they can work out how effective are the features that they discovered in the first phase. So at the end of this phase of qualitative analysis, we are quite sure which features can work to detect, to identify the author of a text. Then we use statistic analysis to verify if these features are significantly different at the statistical point of view, but also we can detect new features, as I said before, that depend on statistics, such as the number of, full stop, which is superior in machines than in humans, unless in Spanish, we are talking in Spanish, and this kind of features. We develop, we need, que me he ido, 8, 7, here. We develop a bunch of software to assist these tasks also. And that's an example. We consider it's interesting of our findings from the statistical point of view. For instance, in this slide, what we can see is in blue color GPT, in red color GPT 3.5, and GPT-4 in red, and some part of speech features. And what you see, it represents the significant difference in use between machines and human. The bars upwards means that human uses more, and downwards machines uses more. So what we discover, it's interesting, is that machine uses more adjective and unique adjective than human beings, and human beings uses more adverbs, unique adverbs, pronouns. That's because machines doesn't know how to make enough for us, and so on. And what is also interesting is that there are no significant difference in the number of nouns, preposition, or verb. So things that the statistical we can discover, but linguists can see in their text. Result 7.
Okay.
is
Thank you
for
very much,
Doaa.
Hannah. Yeah. So I'm going to try to be so brief. Now we will switch to the forensic perspective. Actually, I'm not the one responsible of the forensic analysis, but I am transferring the results of colleagues of the team of Cadiz University, and they are the specialists in forensic linguistic analysis. They have their tools and they have their metrics, which is a different point of view. They check for the likelihood ratio of a text being authored authored by someone. This someone here might be a human, or this someone here might be a large language model, whatever of the 6 that we have just mentioned in the corpus. So this is how the modus operandi, or how they address the problem. They check for the likelihood ratio of a text belonging to a certain author. And with this analysis that they address the corpus, they use the 61% sample of the corpus, not all the corpus, because for them, the rest they didn't have enough evidence, because the forensic linguistic analysis, they are very much abide to the evidence. So if they don't have enough evidence, they will say, I cannot say anything about it. But if they have enough evidence, they would go further with the analysis. So they decided to have only, that they thought that they have enough evidence for 61% of the corpus. And in this 61% of the corpus, they accurately identified if it's human or if it is a large language model. I mean, in a binary way. And to make sure they have really very good results, because they really, in 61% of the sample, they did it very well. And to go further, we tried to make a comparison with another corpus, which is a corpus for a shared task in Iberlef. It's a shared task in Spanish, about also the same problem, identifying if the text is regenerated by AI or if it is written by human. And they achieved, with the same set of features, they achieved 91%. I mean, this completely different type of text, different types of gender, but they use the same features of the linguistic features that they consider they are enough relevant for making the decision. This is on the part of the, in this part. In this column, in the computational, they also we tried another experiment, not very much forensic, but rather computational, using logistic regression with features. And the results for the logistic regression with the features for all the corpus, they were capable of identifying 95% that, of the text, if it is human or AI generated. This is the part of the, this analysis. In order to put all these things and all the pieces together, we are working on a software, on integrity to integrate all these pieces and the different type of features, the linguistic features, and the statistical analysis of the statistical relevance of these features, and also the forensic analysis. We are working on that. It is not yet complete, but we are putting some interest and effort on that, and we are really progressing with very good steps in this software, with visualization to know how these features really help in, and why the evidence, why we consider that this text belongs to an author or another. On another part, we also tried, okay, so let's try another computational approach through classifiers, through machine learning classification, the old school of machine learning classification. And we use different combination of these classifiers in a very agnostic way, not including the features so far. Our objective is to further include the features, but for now we just try to make a baseline and to see what's going on with a very agnostic approach. And we used only a sample of the corpus, only almost half of the corpus, and we divided it as a split train, test, and development, and the results that I'm reporting here are on the test, not on the development set, are on the test set. So we found out that in the whole set of the corpus, in the test, the classifiers, the machine classifiers, were able to classify 90%, or 0.9 F-score. And this is a very good result for this corpus. And also we consider that the quality of the corpus is also very relevant aspect. And then on the other side, we did also an analysis on the different types of text, to see how really it works on the different types of text. And we found out that the best type of text that they are able to differentiate between a human and an AI model is in the reviews. And the interpretation of this result is that the reviews are very subjective. And the human component here is higher than the text generated by an AI model. So this is why here the classifiers really worked very well in terms of a differentiation between the human and the text. The worst category that they worked on is the news, the text of news. And in our interpretation, or from our point of view, the interpretation of this is due that these models are really trained with a lot of text from news and from the media. So they mimic this style so far. So for them it is more difficult to distinguish between a news written by a human and a news really generated by AI text. In the middle, we find the scientific articles. Scientific articles is also a matter of a text which is very schematic, formal, so maybe this is also the reason. And we also, this is the most important part in the classifiers. However, we also did a multi-class classifier where we didn't only give human and machine, we gave human and different authors, different large language models. And the results were not very good because it's like 0.43, so that's very good. That's not very good at all. But yet, we found out that in the reviews, they achieved 0.73. This means that the classifier is able to identify among 6 different large language models who is the author of this text. If it's GPT-4, or if it is the Mixtral or Claude or whatever. However, the worst were the news, and this is why we were penalized in the whole classifier, because the news were really not able to distinguish. So, to wrap up the conclusions of all this work, the most important intermediate results so far is that our proposed methodology, combining these perspectives, really works, and it is very complementary because the forensics consider some aspects, the linguistics consider some aspects, the computational consider other aspects, and really combining and integrating all this comprehensive way of addressing the problem is really working well, and the results are really good. Our next step are going to try to put in this software a way to integrate the different phases and to make a pipeline, so from the features till the computational model, the classifier, the forensic. So we'll try to put all together and to have a visualization for this. And another important conclusion is our main contribution in this part is not only to classify, as Anna mentioned, but to give evidence on why we are giving this decision if it is a human or it's an AI-generated text. Because, for example, in problems like at the university, when the submissions of the graduation projects and theses, etc., it's we can say this text is generated by AI. Okay, but the student can say no, there is no evidence for that. But if we can have this analysis proved by evidence, this gives more credibility and explainability to the question. We need here to give explanation, and this is since we have some linguistic features and we have significant results, so we can give certain explanation for that. Sorry?
No evidence.
So, and of course, the next step is to capitalize on all these intermediate results and to put it all together and to make this software somehow available. And we are also working on extending or having a further step for the project to make a proof of concept. So we are working on it. We hope it will be granted the next step for the proof of concept to make this tool first to continue or to complete developing the tool and to make it available for the at least the academic community or the university community as a small use case. And then further it could be used for other use cases according to the different types. And the important thing is that since we have the methodology, we can adapt it to different types of text, because of course different types of text will give different types of features. So since we have a set of features and we can see how significant they are. And I think that's all. Thank you for your attention.
Thank you very much. Thank you very much for the talk. I'm already seeing like plenty of hands around the room. I think that I can already think of quite a bunch of universities that will buy this. So maybe you become rich in the future. Okay, I don't know where we have. Okay, Jenny's got the so yeah.
All right, so apologies, I've got two questions. Oh, first of all, really enjoyed your talk and good luck in taping this from the lab to production. So I'm sure you'll have a ton of fun with that. My quick question is, what would you consider is the human level baseline for this task? And my slightly longer question is, given that language models are constantly evolving and their stylistic footprint will also change and evolve, how are you going to future-proof the method to adapt, I guess, to the changing footprint of the language models? So sorry, two questions, but hopefully they're not too long.
To the question of how to adapt to new LLMs to appear, the methodology only needs a known sample to work, and at maximum 100 of texts from the author. So it's easy. It's easy. If we can get 100 of texts from the unknown author, it's probably that we can answer the question.
Okay, but if they change, if the language models are changing, that's my question is, how will you adapt to the changing style of the language models?
Simply introducing this known text, the sample of known text in our corpus. That's why we have this systematic way of feeding the corpus. And now we are adapting continuously to new LLMs, for instance, with DeepSeek. When DeepSeek came, we introduced 100 of text to test, to guess the new language feature or the new language patterns.
At the human level baseline, what do you think the human level baseline is for this task? So if you were to crowdsource
the human base, we consider, it's a good question. We consider, which is, we cannot be, we consider that human beings, we have a common or a general linguistic style when we write. That's arguably. But considering it in our hypothesis, it works. Machines write quite differently from us as general persons. Of course, any of us has their own way of writing, the idiolect, what we call the idiolect. But we consider that human beings have a common idiolect that can distinguish, that are different, very different from machines. And up to now, it works, but I don't know in the future.
In Spanish, it's very relevant. In Spanish.
Well, Spanish is very variable. Yes, it's morphological and syntactically it's easier, than in English, of course.
Hi, thank you. Very, very interesting work and well done coming this far. I have two questions. The first one has to do with, you've talked about the forensic side that's been handled by the Cardiff team. So you do Cardiff.
Spanish.
Oh, Spanish. So I thought it was Cardiff in the UK.
Spain.
Oh, okay. My apologies. So, do you know if they are using LLM watermarking at all? Are you aware of any techniques they're using at their own end? Well, anyway, okay. So my second question has to do with, I observed, and as you rightly mentioned, that your news category has very poor results. My thoughts are in two ways. How are you labeling your data, for example? If it's what would you classify as human, and what would you classify as text for the news in particular? And then, could it be that the editors or the journalists themselves, they are writing with AI? So, because the thing is, if somebody has written an article and they called it their own, and I work for, let's say, the newspaper of Spain or something, and they publish it online, you would class that as human, right? But when the model sees it, oh, this is a fellow machine, and then it classes that as a machine-written text. But you say, no, that is wrong. But maybe the model is actually right. So have you looked at it that way, that there is a possibility of what you have labeled as human is actually machine-written significantly? There was a question that came to my mind when you asked that question around evolving LLMs. And now you've identified things like nouns, pronouns, adjectives. What about if people are good at writing prompts and say, look, you are not going to write like a machine, you are going to write like a human. Make sure that you use less of adjectives, and make sure that don't write with specific defined paragraphs. Let's use random lines of text. Boycotting basically all those rules that you have understood. So that could be one way of, let's say, jailbreaking the LLM to ensure that it doesn't identify it as machine-written text.
Right, so regarding the first question about the forensic study, actually, to my knowledge, they are not using very sophisticated, LLM techniques. They are mainly very sophisticated forensic based on statistical and likelihood ratio. So, I cannot guarantee 100%, but to my knowledge, they can give better information about that. Okay. And on the
performance of news.
The news, yeah.
¿Qué era de news? If they are written by, si los humanos han escrito las noticias con machine.
Con machine. We use news written before ChatGPT.
Oh.
Because it could be written with GPT-2, but GPT-2 writes very bad. So the only way is begins with news written before the GPT area. And with respect of prompting using this clue, it could be a good test to do. But what I want to say is that it's a set of features. So you work out, you mix all features, and you work out with all features. And at the orthographic, morphological, maybe syntactic level, you can use it. But at the semantic, when you choose your synonymous or the anaphora, the information extracted, true in this more visual part, but not in the content part. And in discourse level features. These high level features, I think the LLMs couldn't be able to change, because what they have at linguistic level is patterns. So they write with patterns. And how make that the LLM write without patterns? Up to now, it's not possible, but you never know. You never know.
Has your work been published at all?
We are just writing a special issue with all the results. We publish results from the corpus, we write the corpus, and the statistical results. And the rest we are just writing.
Hi. Thank you for your talk. That was fabulous. Okay, so you'll discover in my talk tomorrow, in part of it, that we're actually addressing the same problem about can we detect style in large language models. I won't go through my whole talk, that part of the talk now, but it was interesting because we're taking a stylometric approach, and the reason I'm going to be pitching it tomorrow is because we're developing a large funding proposal, and we're actually looking for computational linguists who can take this kind of approach. So hopefully you will be interested.
Yes,
going back to stylometry, though, I was sort of quite interested in some of the things you were saying in particular, because one of the reasons we use some of the stylometric approaches is that this idea that is it written by a computer or is it written by a human? Of course, the grey area of collaboration is going to be the big problem area, and we tend to find that stylometric approaches help with that. So they enable you to identify whether, for example, Shakespeare was responsible for writing all of his plays, or whether there are other hands in play. So it'd be interesting to find. It's interesting to see how you want to take this further, and hopefully, you've shown us yours. I'll show you mine tomorrow, and we can maybe kind of do something together. Yeah. Thank you. But thank you. That was great.
Thing here that we really there are a lot now of ads about tools to humanize AI text. So that's I believe they are doing the same, like trying to figure out the features and to humanize it to get away these features. So
sorry.
Yeah, sure.
The thing I find fascinating is that humans, we don't have a style. We all have a different style.
Yeah.
This is the thing we have to address. That it's not as simple as saying to a large language model, "Can you write this in the style of a human?"
Yeah, which human?
And hide the fact that you're a large language model, because that in itself is quite a complex question.
That's true.
And there are questions for using for easily distinguished, but are very hard to do an automatic tool, such as human being. Put their opinion of the life, their spirit of the life in the test. And we realize when the text is written by an LLM because it's plain. It's plain. There is no life. And our linguistic team recognize quickly because there are not alive texts. But how do you formalize this? How do you translate it to a computational tool?
Is this working? Okay. Well, firstly, thank you very much for such an amazing and comprehensive analysis. We have some online questions. The first of them is if you use local versions of the models or just online versions. And also, how do you think these analyses would work with semi-human productions using tools such as Grammarly or Trinker, which provide AI language suggestions?
Yeah, we are using now the best the LLMs that write very well in Spanish. That's one of our criteria. And up to now, there are Gemini, GPT, Claude, Mistral, and DeepSeek. Some of them are open,
Open source
and others
yeah.
are private, and we pay for using it, of course.
Of course.
Claude and GPT-4.
But they meant like these kind of tools, online tools like Grammarly, that they make some suggestions when you're writing.
No.
You haven't considered this? All right, well, it could be interesting for further research,
Yeah.
of course.
And there is another problem that we don't face, and it's the hybrid text. I mean, the paraphrase, when a human took the text and paraphrased it, we don't work in it.
All right, thank you.
A harder problem. Muy bien.
I've just got a question. Hello. Just one
there
quick
is
question.
another question.
Yeah, just a really short one.
You may, yeah, one quick question, and we may continue in the meeting if that's okay.
Okay. Shall I just do it? Short, absolutely short. So you had 3,832 texts you mentioned. So that's quite small. At the same time, how have you managed to balance it? Because if balance data throughout the whole of, if it's not, if there's any sway towards imbalancing, it's going to have an impact. How have you managed to ensure that? And I think it's your results as good as that balancing.
In fact, for our methods, we don't need to have a lot of text, and we don't need a well-balanced corpus. We need limited number of what is known tests for the forensic team works. What is true is that when we began with a classifier, antibiotic classifier, we will need or take care about the question of balance. But up to now, it's not necessary for us. That's another advantage of these linguistic methodologies, no? That you need less data than the IT approaches.
Thank you very much. Let's thank our speakers, not only for the presentation, but also for answering all the questions. Thank you so much.